Alright guys, so in this video we're going to continue to look into slope, and specifically looking at slope with a little bit more of a real life example or circumstance that we are dealing with. So let's take a look at this example here. Again, the goal is to dive into slope and how does it kind of relate in some real life application here. So the revenue per share for eBay Inc. was 20 cents and 98 and 91 cents and 99. Using only this information, write a linear equation that gives the revenue per share in terms of the year. Then predict the revenue for 2000. Well, let's kind of start some things on off. Again, think about what we're trying to represent in terms of slope. I wanted you to think of it as change in y over the change in x. That is what our slope is going to represent. Well, let's think about this in terms of our problem that we are dealing with, right? So the change in y, well, what is y in this particular example? Y is going to be revenue, right? Why is revenue happening? Because of the year that you're in. Think about what's changing is the year, and then what is causing the value to increase? The year. And so what we're really looking at is the new revenue minus the old revenue, that's our change in y, over the new year minus the old year, or the starting point. Right? Well, what does this look like in terms of our new revenue and our old revenue? Well, we're diving on into 1999. So in 1999 was our latest thing that we're dealing with, and that had a revenue share of 0.91. And then in 98 it had a revenue share of 0.2 or 20 cents. All right, well then what are we dealing with in terms of our time? Well, we don't really have a starting point other than 1998. So we have to go ahead and assume that that's going to be t equals 0, and 1 year ahead of 1998 is going to be t equals 1. So our new year is 99, our old year is 0, and doing the division we end up getting about 0.71. All right, so this is our slope. This is the slope. This is m for our equation that we are trying to find. Well, what are the actual points that lie on this graph? Well, if t equals 0, our graph, right, is a verdict of t to r, right? T to r, revenue to time. That's really what we're dealing with in this case, where r ends up being our y in this example. Well, all of these points that we have, when t equals 0, we had a revenue share of 0.20. Right? When t equaled 1, so just 1 year after it started, we had a revenue share of 0.91. So we had a value on over here. And so the goal is to find out what the equation of this line will end up being in the end. Well, we already have our slope. So that means we have 2 points. The points that we know so far that are on the graph are at 0.20 and at 1, 0.91. Alrighty. Well, let's use one of these. We just talked about point slope form, guys. So y minus, I'm going to go ahead and use 0.20 in zeros because it's usually easier to use a 0 if can. So we'll put our y1 in there, equals our slope, which was 0.71, times x minus 0 in this case. So y minus 0.20 equals 0.71 times x, because there is nothing multiplied by 0. And y equals 0.71x plus 0.20 when I add it on over. And that is the equation for our line. Well, if we go ahead and incorporate this concept into predictions, I can use this linear form to predict what's going to happen. Well, think about it. In the year 2000, then t equals 0, right? In the year 2000, t will equal 2, right? So 98 was 0, 2000, t is going to equal 2. Let's use that to our advantage here. Because remember, x really was t in this case, right? X is the independent variable and t in our case here. And substituting it on in, y equals 0.71 times 2 plus 0.20 will roughly get us 1.62. So our dollar amount is going to be about 1.62 if we're using our predictions of this linear equation here. All right, guys. So as we continue to kind of push a little bit farther here, want to look on into just a refresher of what it means to be parallel and perpendicular lines. Remember, parallel lines have the same slope because they do not intersect. Well, what about perpendicular lines? And we called it opposite reciprocal slopes. Opposite reciprocal slopes when we have perpendicular lines. All right? Well, using the information from the example and using the information here about parallel and perpendicular lines, if you'll do me a favor and please solve this one on your own, and we will go ahead and move right on to the next one.